The greatest common factor of two or more polynomial terms is the largest factor that will divide all of the terms evenly. Okay, so to get a feel for this, we're going to take a couple of expressions, 10x cubed y squared and 12x y to the fifth, and break those down into their individual factors. And then we're going to look at what factors are common to both, and we'll get a feel for how to find the greatest common factor of both of these. So with 10x cubed y squared, I think of 10 as 2 times 5. 2 and 5 are both prime factors, so that's broken down nicely. And then we have x times x times x, which is x cubed. And for y squared, we're going to have y times y, right? Okay, so that's as far as we can break it down. And now with 12x y to the fifth, so with 12, we've got 2 times 6, and of course 6 is 2 times 3. Okay, so thinking about that prime factorization again, and then we just have x, and then we have 5 y's, right? Y times y times y times y times y. Okay, so what's common to both of these? Okay, well, I see a 2 is common, right? I'm going to circle that one. And of course, the second one has another 2 in it, but we can only include 1 because there's only 1 in the first one. And then what's common here? Well, there's an x that's common, just one of them, right? And then how many y's are common? 2 of them are common to both, right? So what would the GCF of both of these terms be? So we got 10x y squared and 12x y to the fifth. Okay, so based on what we circled, we're going to have a 2x y squared. So every time you look at two expressions, are you going to write out the prime factorization and circle the stuff like we just did? No, right? You're going to get real good at this. So let's just take a look at this for a second. Just look at the numbers, 10 and 12. Well, I know they're both even, so 2 goes into both of them. Does anything bigger than that go into both of them evenly? So 5 goes into 10, but that doesn't go into 12. And 3 goes into 12, but that doesn't go into 10. Right? 4 goes into 12, but that doesn't go into 10. 6 goes into 12, but that doesn't go into 10. So 2 is the only thing, right? So then we look at the variables. So both of them have an x in them. The second one only has 1, and the first one has 3, okay? So, but they both have at least 1 in common, right? So we're going to include that one. And then with the y's, the first one has 2 of the y's, and the second one has 5 of them. So both of them have at least 2, right? Okay, so y squared is going to be what's common to both of them. Okay, so that's just a little bit about how to find the GCF. So this is a good introduction to finding the greatest common factor of two terms, okay? And also note, when we're finding the greatest common factor amongst the variables, notice that in each case here with the x's, I took the lowest power of x that I saw, right? I had an x cubed and an x, and it's just x that appears in the GCF. And with between y squared and y to the fifth, it's just y squared, right, that appears in the GCF. Okay, so just some things to note, and this is a good introduction to how to find the GCF, and now we're going to get some more practice.